my plan is to bore you to death in the last 30 minutes of the day. But I put this together also so that this could be a reference, and we can talk a little bit about data dictionary and the current state and how we are seeing data dictionaries evolve over a period of time. So without trying to overload you with a lot of technical details, I'll cover some things in a very high level, but we'll start simple, and hopefully we can associate it with some of the data dictionary work that's happening here. I know if this is too bright, but if this is not readable, just raise your hand at the back. So the plan is, we want to talk about the why. I think everybody knows that's why you're here, hopefully. That's why you're here for the data dictionary. We want to talk a little bit about what is the content that we want to capture in the data dictionary. Who captures that content? A lot of the times we hear IT will create the data dictionary, business users will create the data dictionary, or data offices will create the data dictionary. We want to understand a little bit more in this session who is it that is creating that data dictionary. And given that content that needs to go in the dictionary, what exactly is everybody going to do as far as the data dictionary is concerned? And how they're going to create it, that's another piece that's important. We'll go through some examples, roads, bridges, routes, those are the kind of things we'll look at and talk about here. So I'll show some data dictionaries from some of the other enterprise systems that we have worked with, and the forms and formats of those data dictionaries. Just again, to kind of represent the whole landscape of things there. And then we'll talk about semantic standards, what those standards are, and then we'll actually go step by step looking at how to build that data dictionary by using those semantic standards. That's kind of the idea here. Okay, so first of all, why data dictionary? This is a graphic that has been put in the National Strategic Roadmap for the Advancing BIM for Infrastructure. It is also part of many of the other national BIM research projects that FHWA has led. And the basic idea is, at the bottom, we basically get our digital processes or process models or business workflows. And once we have defined those, we want to identify what data is actually getting captured, created, collected, and exchanged across those data formats and data exchange and process models. So the data terms and terminology essentially comes in next at the second level. And then you start using that, put it in a data dictionary where you start defining, here are the data entities I'm capturing, here are the object types that I'm capturing. Just a very simple example of an object type. A bridge is an object type, a road is an object type, a tunnel is an object type, a culvert is an object type. So we're talking about that kind of dictionary that we're creating. And we're creating that so that we can actually then go ahead and those information exchanges that we're dealing with, we can actually make those data information exchanges happen. We can make those information exchanges happen through APIs. We can make those information exchanges happen through automation by ensuring that people can read data from system 1, system 2 to system 3. And there is not a lot of constant transformation of data that we have to do from one system to the other in order to understand how data is captured in one of the places. So if there's one key message here, it is in order to ensure that data exchanges happen through APIs and the automation can actually happen in data exchanges and data interoperability can be scaled, it is very important to have a standards-based data dictionary, and that's number one reason we say. Machine-readable data models and ensuring data quality are some of the other important reasons that are key. Overall, better information modeling or better information management is one of the key reasons we want to focus on these two steps. And standards play a very key role here. So let's take a quick look at what is the kind of information that we want to capture in a data dictionary. We want to obviously, these are not necessarily a laundry list of everything that it should capture, but again, probably 25, 26 items that I think are the most important that should be captured. Starting with data elements, which are essentially which object I have, what is the name of that object, if it's a bridge, it's a tunnel, it's a road, or whatever else. What is the definition or description of that object? When I talk about a road being an object, is the road something that actually also includes multimodal network, wherein we talk about pedestrians and sidewalks, in addition to the motorists? Are we talking about trails? Those are the kind of things we talk about. Data types, whether it's an integer, decimal, character, piece information. Many of you are probably familiar with data formats, length, precision, accuracy, resolution, and all of those things. The first column is fairly standard. But I think on the right, when you talk about data element relationships and dependencies, I should be able to know what are the attributes associated with a road in system 1, which is a design system, versus in system 2, that is a linear referencing and a GIS system, versus in system 3, that is a construction management system, and which attributes are in which system of record or source of truth, and quickly do a query of my metadata and identify all the data that is associated with the road in an automated and seamless manner. That's our goal. So data dependencies and relationships captured, data usage captured becomes very important. Who can access what data security becomes important. And then talking about version management and most important, number 26, URI, the Uniform Resource Identifiers. How many of you know? I'm pretty sure some of you would have seen this. URI, at least one person. So these are very important. We'll go through all of this slowly so that we can see what each of these things are. So the way the entire presentation is laid out, I'm going to break these down into pieces. I'm going to talk about who's going to capture each one of these items in a data dictionary and how and what does that mean in terms of the maturity of the data dictionary. So the 7 steps that at least can be 8, you can do whatever you in terms of the number of steps, but just very high level, we say start by identifying a data dictionary is step 1. Typically data offices do that. We often start with IT and database administrators, DBAs, and we say go into system 1, go to the database, extract information from that particular database, and get me the list of all the tables and columns and all the relationships, primary key, foreign key, and things like that. And that's great. And I think that's level 1, that's step 2, but that's not it. There is much more that needs to be done. Once we have extracted information from the database, often those databases don't have terms and definitions that have been defined. Sometimes they do. If they do, great. If they don't, then somebody who's a data owner. When I think of a data owner is a person who is looking at his road or his bridge data across all the systems in the organization. Whether it is your construction Ashtovare system or your entity or Autodesk design system or your project management system or your asset management system, it doesn't matter. A data owner knows this is my data and this is where it is across the 500 applications that are typically set up in an organization. So this data owner basically understands and he can consistently define terms across all of those systems, and that's where the terms and definitions become important. You hear a lot about information requirements using ISO 19650. This person actually defines those information requirements for data, and he also therefore is able to identify the systems of record or the sources of truth and a life cycle of data, where he can actually see through how the data traverses across all the different applications, across all the different stages, across all the different asset lifecycle stages as well. So this is that data owner needs to basically work after the DBA has pulled out your data dictionaries from individual systems or applications. You then get into data standards SME. This is a person who's actually very well versed with the likes of IFCs or OGC standards like InfraGML or CityGML, or basically who's very well versed with any of the ISO standards like ISO 254, and we'll look at some of these. But essentially somebody who actually knows standards and how the standards have actually defined terms and definitions in the industry, both national and international standards. So that then he can advise, he or she can advise the data owner that this is how the data terms and definitions could potentially be aligned with the standards. That's where the semantic standards part comes in. Then you have data stewards. Data stewards are people who actually edit the data. They're different from data owners in the sense that data owner could be 1 or 2 people, but data stewards can be many. Data stewards are sitting in across different applications, and each application could potentially have a data steward. And the idea of the data steward is he or she is a little bit more into the weeds when it comes to data, because they are actually editing the data. They are able to talk to the data quality, they're able to talk to the business rules, they're able to talk about how the data is actually being captured and what are the nitty-gritties of the data collection process. The data engineers or architects come next, which basically these people take information from all of the previous steps and then architect the data. A lot of the times this role is considered as similar to a DBA, but a database administrator is a database administrator. He actually is more in charge of how to set databases are operational, archiving the data and things like that. There are technical elements associated with it. A data engineer understands the data almost as much as a data owner, and almost as much as a data steward as well. And they also understand standards. And so one of the main things they do is they architect the data and put it in certain formats and structure. And we're going to look at some of those as well. And finally, a metadata analyst. Yesterday, Trisha mentioned Trisha from Semantic, that one of the things you have to do is you have to report things out. You have to put things out in front of everybody so they can see what is the state of your data dictionary or what is the state of your data in general. The same thing applies to a data dictionary. If you don't query your data dictionary, if you don't actually analyze it, if you don't actually put reports out on it, then it is very difficult for people to know what is in the data dictionary. I call it a metadata analyst. It is a data analyst role, but the idea of this person is this person should be able to query the metadata and should be able to identify where a certain data attribute or data entity is in the entire ecosystem, if we have done all the modeling in the architecture, right? So these are the different roles we think of in terms of data dictionary management. So let's look at the first set of these things, right? Let's go into an example and let's see how, where we might get these. These are the things that we may get from a DBA or an IT person. One thing I want to say is, so all of those different pieces of information that we saw and the different roles that we saw, we're going to distribute them across the 3 levels of maturity for data dictionary. Now, the idea with this is your IT DBAs essentially creating the data dictionary is at level 1 at a very high level. Your data owners coming in, defining terms and definitions, mapping to some standards, semantic standard libraries and properties being brought over, those data life cycles being created, those are at level 2. And at level 3, your data stewards and architects and your metadata analysts are able to do the things that we talked about. And this is where you're actually talking about that uniform resource identifier, data element relationships, and the various structures of data, the resource description framework, and a few other things that we talk about. So again, too much information, sorry, but the intent of this is to basically lay out at least the spectrum in terms of how we can look at data dictionary. Organizations can be at any level when it comes to data dictionary, but important thing is to realize that there are levels of data dictionary. Okay. So the first thing we're going to do is we're going to go to that IT DBA, we're going to wear that hat, and we're going to basically go to various systems, right? And we're going to find what is the data that's available, and we're trying to do level 1. We will go to a transactional system like a project management system or a roads asset management system, and we can also go to a data warehouse, and we will look at how the data dictionary can be extracted in a geodatabase. By the way, data dictionary is not just about structured data, it is also about unstructured data like documents, LiDAR data, and imagery data, and things like that. So we'll talk about that as well. Simple example, like I said, project, roads, bridges, that's what we're going to look at. So this part covers the first 3 steps, which is where an enterprise data dictionary lead has called upon an IT DBA to go to these systems and basically extract the information about the database tables so that the data owner can then add terms and definitions corresponding to each of the objects and the attributes. Well, I can't see this very well from here, but let's see if this will come a little better now. Hopefully this is a little better. This is an example. I gave away one of the answers. I was going to ask which system this is coming from, but the answer is it is coming from an AstroWeb project application. It is a project management system. What you're seeing on the far left, there is a table in that particular database which is project table, and so the first column shows you table name. Then you have column name, which are essentially showing all the different column names that are there. You're obviously not seeing all the different column names that are available in that particular database. It's just a sample. The type of data, the information about if it is a character or it's an integer, you know, what is the length of that particular data field and so on and so forth. And on the far right, you're basically seeing columns with information about what each of those data attributes are used to capture information. This kind of data dictionary, how many of us are creating this today at any of the agencies? So this is the most common form of data dictionary because we can easily get that information from the databases. Similar example here, same from Ash2Web project as well. This is now actually pulling in information about road segments. And then there is a third example right here, which is pulling in information about routes or road segments here. And just looking at this in a little bit more detail. All of this information is actually coming from the same system, which is the Ash2Web project system. We looked at roads, we looked at bridges, and when we looked at roads, we looked at projects here. One of the main reasons I pulled up the route table from Ash2Web project was because now you're coming across a redundancy here. Routes are not just in Ash2Web project. Ash2Web project is a construction management system. The routes are actually being modeled in a construction management system so that you can locate your projects on those routes. But the master or the system of record for the routes are actually in a linear referencing or a roads data management system. So the same route table will also exist in a GIS asset management system. And so now we are basically looking at a scenario where we asked our DBA to basically give us a data dictionary with these 10 attributes that are there, with route ID at the far end at the bottom for that particular route, but at the same time there's going to be another route ID, road name, and many other attributes that will come from a GIS and asset management system, and we have to put these data dictionaries together to basically create an enterprise data dictionary. Okay. So let's take a look at that GIS system, that roads data management system next. So this is just again a grown-up version of that same route table that we were seeing here with Ash2Web project. And the main thing that I wanted to highlight here is the second last row, which basically shows a route ID that basically is defined as a unique identifier for that particular road on which we're going to locate the project. Okay. I don't know why these things are washed out here. They look quite fine to me here on my thing. But anyways, I'll just quickly mention this here. So this is a data dictionary that has been created from a GIS system. And one of the main things that we are basically looking at here is on the far left, again, there is a list of all the columns that you have. But one of the things you see on the right, if you're at least able to see the MIRE and the HPMS, the MIRE part, what these people in the data dictionary have in the LRS, the GIS system, or the roads data management system have done is, for each of the attributes that they have mapped it to one of the national standards, which is the Highway Performance Monitoring System, or for that matter, the manual entry of roadway elements. Now there are 70 HPMS data items, and there are 204 MIRE elements, and all of those are essentially listed in this particular data dictionary. Road ID and road name and some of those other attributes also come in this particular picture. So this is now your road inventory system pulling the data and giving you a data dictionary from that. Let's go to our design systems. Design systems, we don't get databases like that very easily. Most of our DBAs will not know how to access information from the design system. Sometimes you'd be lucky to get plan sheets like these or Excel documents like these. This is an example from Iowa DOT. I don't know if anybody here is from Iowa. Got this a long time back. Essentially what you're seeing here is, up at the top, there is information about from station to station. There is a route and road segment right here as well. I don't know if the mouse will work, but right here is the route, and it's basically getting information about Route 51, and then you've basically got from station to station, and then you have some other attributes like median type, median width, change of lanes, and surface width, and so on and so forth. Right here is how you can extract information about your data dictionary elements from this. How do you extract it from design systems? It's almost a manual exercise sometimes in our agencies today, where if you're lucky to find these sheets, you can actually go and get that from there. If you are able to look at plan sheets and PDFs, you can see the annotations of text and information you can get from there. These days we are always creating item types, and we are creating more intelligent CAD models, and that's where we are also documenting information about attributes, and those attributes can also be the pieces of information that can be added to the data dictionary. And a similar data dictionary as in the GIS system can be actually created there. So the key thing again here to note is when we talk about median type, median width, shoulder width, and these attributes right here, these are also captured in the GIS system. So now again there is redundancy in terms of data dictionary and the attributes. Okay. Am I losing you? Everybody with me? Not everybody, right? Okay. So we are 20 minutes into it, and I've not covered a whole bunch. But again, the idea is to basically provide this as a reference so that you can actually see this more. I'll cover some of the slides now quickly. So what we're basically ending up doing is that DBA is going to basically go to our project management system, our design, construction, road asset management system, traffic safety. So every system is going to give a data dictionary. Every system is going to give you an Excel spreadsheet. There will be a lot of redundancy in attributes. Sometimes the terms are not going to be same. And we're basically going to say, how do we create an enterprise data dictionary with all of these 20 documents that are sitting there? Right? Number one problem today in our agencies. This is where the semantic data standards come in. If we can map all the objects and the attributes in that data dictionaries and all those data dictionaries to open the standard in terms of the terms and definitions, and that's where the data standards SME comes in, then we can actually create a hook. We can say a road is a road. I don't care if somebody said road Abhishek and somebody said road Mike and somebody said road John. As long as I'm basically saying that all of those three types of roads across all the different data dictionaries are mapped to that one road entity or object type and the property associated with it, that's what I'm looking for. Then I can actually pull the rope and basically get anything out from in terms of using that local standard. So the data standard SME comes in now, and the first question you ask is, which standards are available? So the data standard SME is saying, I'm going to focus on these things right here, but most importantly, I'm going to focus on number 25. I'm going to give you data standards. And I'm also going to, from the standards, extract information about some of the relationships and dependencies. As the data standards SME does that, he's also going to work with the data stewards, because data stewards are now in charge of the actual editing of the data. Data owner is a little bit higher level. Still data lifecycle level, systems level, doesn't know so much about the standards and the specific entities and object types. Data stewards do that, so they're going to work together, data standards SME and data stewards. So let's start going to the standards then. So this is just a list of few standards. There are international standards, Building Smart, IFC, Industry Foundation classes, and the Industry Foundation classes is basically a set of classes with properties and attributes that have been basically exposed and published in the form of a Building Smart data dictionary. Building Smart data dictionary does not actually expose all the object types and properties that are there in the IFC schema, but whatever is important, a lot of them are available through the BSDD dictionary website. We'll look at some of that as well. Then there is ISO standards, there's Open Geospatial Consortium. These are international standards. They're meant to be high level, they're meant to be very general, they're meant to be just defining object types, entities, and not get into the details of properties. All of these standards allow you to define properties on your own. And this is where we as national groups come in, where we have to define national standards, and we have to do something like a national bridge inventory and basically take the 150, 110 attributes of bridge inventory, or the HPMS system where there are 70 items, or the Meyer system where there are 150 items, and start adding properties and definitions on top of that. Right? So these are the standards that your standards system first puts on your table and says these are the things. Okay. There are also committees like ASHTO, JDCES that's actually working on defining the model element breakdowns, and this is basically for the design models that have been created. So in addition to anything that has been developed that has been used as a reporting standard, if so, like the ones on the previous slide, this one we also have to basically look at what some of the committees are doing, and your standards SME is again well aware that these kind of standards are being developed by committees like the ASHTO, JDCES, and are under constant discussion, or the BIM pool funds that we are talking about yesterday. So again, that's what should be going on in the SME's mind, who is a standards SME, in terms of how am I going to go about creating the mapping of the standards to the object types that I have. So once that happens, then what the standards SME is doing is it's going to take each of the objects that he has from any of the data dictionaries that are created across all the different applications, and he's going to start mapping things. Let's say twice, right? Just one of the international standards. He's going to say, I'm going to take that concrete driveway, and I'm going to basically model it and map it to IFC ramp. I'm going to basically take the sidewalk, I'm going to model it as IFC road park sidewalk, and so on and so forth. What this SME will very quickly find out, sometimes there is an object and a property that's in the open standard that you can easily map an object to. Sometimes there are no such properties that are in the open standard, and we have to again look for multiple other standards to see how you can combine these standards. Sometimes we find that there are multiple standards that are conflicting with each other, and And there are two standards of defining the thing differently, and you basically end up mapping it to multiple different standards. That's where the adoption of a particular standard as an organization becomes important. But the mapping of the standard is the key. So FHWA did look at this idea of multiple standards, and one of the things we said was this was done as part of the National BIM Transportation Library research. And we said, let's start at the bottom with all of those international standards, which are the IFCs, the OGCs, the World Wide Web Consortium, the W3C standards. They have IFC, OWL, ontology, web languages, and things like that. And we're going to basically start with all of them, and we're going to identify all the different object types that are now there in the standards. That graphic on the left is now actually going to identify object types not from your individual applications or systems. It's going to identify object types across IFC, across OGC, across HPMS, across MBI, and it's going to basically find the overlaps and the redundancies there. It's going to find how they are actually mapping. This is, again, something that's happening at the national level now, but your SME, your standards SME is aware of this thing. So when that happens, then this SME is basically able to define, here is how I'm going to be able to leverage a standard across the board in terms of mapping into the dictionaries. Okay, these slides are communicating the same thing. The basic idea was there is going to be a national data dictionary that we would develop in the United States that would basically allow for all of these international standards and the national standards to come together to create a national US data dictionary for all the different data objects that agencies will have. So that that dictionary can then be published to the states, and the states can use that as a starting point. That is what was captured at least in this particular research when we talk about the National Web Transportation Library. So the idea here is take your IFC, take your OGC, take Arnold, HPMS, take Ashtovare data dictionaries, put them all together and publish an object type and property set that actually is available through an API as a national data dictionary. And then the states come, and the states say, we're going to start with the national data dictionary, and we're going to start bringing in data dictionary from all of our individual systems that we saw earlier, and we're going to basically create a state data dictionary. Okay, so does your SME, is this person done yet? There should be actually need and content, and this person should be aware of how to actually navigate through these standard data dictionaries that have been published. That national standard data dictionary in the previous slide, we basically said there is a national standard data dictionary. Right now, we don't have all of these combined, but let's say this part right here has been exposed through that API, right? And so this is what you can start with today. And so you're saying, okay, this piece right here that I'm going to be using as a starting point in my state, I'm going to basically take this national dictionary, and it is available on GitHub, it's available through API, and that's what we're looking at as one of the building smart data dictionaries. So this is the lowest common denominator. This is basically identifying roads here. And we're basically seeing how the road is defined and the description of it, but one of the key things we're basically seeing here is information about the Uniform Resource Identifier, which is a unique web address that has been assigned to each object in your data dictionary, just like a website. Like you go to google.com or you go to amazon.com, URI basically identifies every single object in your data dictionary so that it can be published to the web. And that's why it's called a resource identifier. It's available for road, it's available for a group of properties of roads, and it's available for also the properties like lane width, shoulder width, leading width, some of these, and that's what your standards SME is putting together at this point. Okay, so your standards SME has identified all of these different standards, has identified which properties get mapped to which standard, which object types get mapped to which standard, and now this person is ready to transfer things over to the engineer or the data architect. I have 1 minute, so I'm not going to cover this section. But at a high level, I'll tell you this. When we talk about data engineer and architect coming, we are graduating from putting a data dictionary in an Excel spreadsheet. We are graduating to ERDs, UMLs, the entity relationship diagrams, the unified modeling language, and the resource description framework standards. When we use LinkedIn, you have these things like second connection, third connection, fourth connection, right? How does that happen? It happens through graph data models. Your data dictionary has to be established as a graph data model so that you can basically pick a property like lane width, shoulder width, median type, and you can basically navigate through the 15 systems and the multiple hierarchies of those systems and quickly extract information about where all that property appears in the entire ecosystem. That's why the architect and engineer becomes very important. That's the essence of this section right here. And so there are steps here in terms of how this person is going to use the URI that we saw in those standards, how they're going to work with tools like Enterprise Architect to basically pull all of that information together, how they're going to create these kind of ERDs that are available, and how these ERDs are then going to be actually used to create the resource description framework. And so there is the whole idea of subject, object, predicate, triples, and things like that. And there are these kind of graphics. Not that I thought I would be able to cover this section. But again, just some information. Feel free to reach out to me if there are questions here. At the end of the day, there is a lot of coding and development that comes in here when it comes to actually going to this third level. But now you're also managing the data and all this data dictionary through version control systems like GitHub, and that's something that has to be looked at. And all those version control systems, you have the states at the bottommost layer, and you have the national transportation library or the data experts who have defined the national data dictionary working together in the same version control environment to manage all of these things. All of this is, again, the sources are there in all the slides, so you can actually go and see where we are essentially getting this information from. But bottom line is those are the 7 steps, and when it comes to level 3, we didn't get into level 3 because that's going to overload us with a lot of information that we don't want to cover right now. But at the same time, we talked about levels 1 and 2 in terms of what the ITDBA can do and what the standards part can do for us. And with that, I'll stop. I don't think we have time for questions, but I'll still take any feedback.
So I will say, thank you very much.
Thank you. Just this is fantastic. Just for a second. If you've got a concept different areas and needs emphasis on others, in other words, say it starts with your point.
That's where the data is stored and the standard SME has to come. So standard SME would basically say a route could be a freight route, a route could be a bike route, a route could be a pedestrian route, it could be a motorist route, and all of those routes are used to define how you're going to traverse through the network of roads essentially. So your data stored is going to basically tell you that, and data stored in your RMS system, GIS system, that's those people are the ones who actually define it. And the standard SME will probably also come in and say, nationally, the GC actually defines for that how a road should be. And they would basically crank their heads and basically come up with here is the balance. They would have to do that.
I'm just listening. Take your
Okay.
time. Yeah.
So the other half question is that so you what semantic defines the dictionary or properties or attributes? So now if I've got semantic, I've got standardize those as much as possible across the
Yes. So one way you do that is this piece right here. So this is a property set from IFC. So they've defined design speed, design traffic volume, design vector. They have done that across the board. But your standards SME knows that there are out of the 1,000 properties that you have in roads, there are 10 of them that are defined in standard 1, which is IFC, and 10 that are defined which is standard in the GML. There is a little bit of an overlap. This person actually
sorting that mess out is the
it's
Yes. The ones that that's of amount of work.
That's what I'm saying. It is, yeah, it'll take us 100 years. We've been solving the problem for the last 100 years. Yeah, but this is how everything.
We've got a lifetime.
Job security.
Yes.
Thank
You'll just become
No, I think they're challenging, like, the way you're bringing stuff in and all that stuff.
Simon really has an eye who can actually fix this. One of the very few people in the industry who can actually fix this.
which probably means I'm not getting any of the time.
He's done that
Seems you're valuable, right? Thank you very much, appreciate it.
Yes, and I was almost thinking I need an hour, but then I didn't. These are the kind of things that we are supposed to do, right? It's good. Yeah, how are things for you? You guys are so many years. This is just one of the things that people are doing because now we have the ideas that we develop marketing is I was actually trying to build up a combination to extract information. It is a work in process. It's actually what I'm doing is I've taken author imagery. I'm actually we talked about it more at Jedi. So it's here. But essentially we've taken author imagery. From that we're extracting those by actually looking at a script that actually travels through the author imagery. And then as we extracted that information, there is vector data, and there is animations, and there is information from text that we extracted. Now people are always looking for, yeah, this is a 7, this is an 8, this is a cat, this is a dog, and all of that is computer vision. So one of the CNN models that we developed is basically meant to actually read the data that's in these maps that have been digital guided maps and the imageries and automatically create the GIS representation of it. And in doing that, this kind of standard deviation is super important because we have to actually know what's going to be the GIS. Actually, using those URIs that are available. It's R&D. Yeah, you said that's tomorrow? I will not talk about all of it tomorrow, but there's one slide for Kickstart that we're actually showing. We talk about the Jedi project, there's one slide where we will talk about data analysis, where we will talk about being able to engineer these things using AI techniques, where you don't have the use cases. People are trying to model divided highways. This other side of the coding that allows us to GIS systems. extract the roads, the